Today, at this point right now, it is the day before Bedlam. Okay, so hopefully when you're watching this, which will be after Bedlam, the OSU Cowboys of Stillwater, Oklahoma won, beat the Sooners of Norman. Go Pokes. Hopefully, again, that the Cowboys pulled through this year for Bedlam. And if not, then this will be a very sad video rewatching it in the future. Okay, let's get started on some maths. So today we're talking about 8.3 rational functions and their graphs. So our objectives is to identify properties of rational functions and to actually graph them. Okay, so let's get started. So we have, with rational functions, it's of the form p of x over q of x. And so you're gonna have linears, you're gonna have quadratics, so cubics will probably not, but not in this example, but you can have all different kinds of different things on the top and the bottom. So in each of those give you different characteristics of your graph. So we have continuous and discontinuous. So continuous looks like this. So we have x squared over x squared plus 1. So from left to right is a continuous graph. There's no holes, there's no asymptotes. It is what it is. It's a continuous graph. Now we have discontinuous. We're either going to have holes or asymptotes. And we're going to look about how we can find a hole, how we can figure out if it's going to be a hole or an asymptote. And then we're going to look at how to actually graph these. So again, this is a hole where it's from left to right, it's going up continuously, but at -2, there's a hole. And if you think about it, we can't have an x or a 0 in the denominator, and this is why, right? X plus 2 equals 0, minus 2, at -2, there's a hole. Here, at 2, there's a vertical asymptote. And then we also have a horizontal asymptote, which we'll find in just a second how to find those. But you can either have continuous or discontinuous at certain points. And you may have holes or asymptotes. So let's get started. So figuring out points of discontinuity. Where your graph is discontinuous. So you cannot have 0 in the denominator. It's illegal. In your spare time, ask Siri what 0 divided by 0 is. She tells you this long story about the Cookie Monster, and it's real funny. But you cannot have 0 in the denominator. So keep that in mind, and that's how we're going to find our vertical asymptotes and or holes. So first, let's talk about, we have x plus 3 over x squared minus 4x plus 3. Whenever you're doing these problems, the first thing that you always need to do is factor if you can. Factor out the top, factor out the bottom. You may have to factor both. You may have to factor one. You may not have to factor any of them. So let's look at this. We have x plus 3 over x squared minus 4x plus 3. So this top is just a linear, we're good. Bottom, we have a quadratic trinomial. So we're gonna need to factor this, or see if we can at least. Oh my goodness. Hang on one second. This is the second time I've had to do this. We're just gonna go real quick and hopefully it'll work. I don't know why it worked. I practiced and then I recorded and it didn't work. So I did it all again and I practiced and it worked, and now it doesn't work. Thank you. Okay, we have x plus 3 at the top. We can't factor that at all, but x squared minus 4x plus 3. Let's see if we can factor. We have to think about what two numbers multiply to get 3, but add to get -4. I know Mr. Thomas and I kind of go about different approaches. I do an x, our 3 goes at the top, our -4 goes at the bottom. So the factors of 3 would be 1 and 3. 1 plus 3 gives us a negative, but they both need to be negative. -1 times -3 gives 3. -1 plus -3 gives -4. So those are going to be our factors, our x minus 1 and an x minus 3. If you're still struggling with factoring, reach out to us. You have to be able to factor to do this lesson. So if you're still struggling with that, we've got to work on it and get better, because we should be able to quickly go from here to here. Okay, so we have factored the numerator and the denominator. Now we need to see if there are common factors. So like here we have an x plus 3, we have an x minus 1, and we have an x minus 3. Okay, so those are similar, but one's a positive, one's negative. So we have nothing in common. Okay, so that means the function is undefined where x minus 3 equals 0, and then the x minus 1 equals 0. Okay? So we solve for x. So we add 3 here to both sides. We add 1 here to both sides. So at x equals 3 and at x equals 1, the domain is a function except for at those points. Okay, we do not have an x value or a y value when our x is 1 and 3. So there are non-removable points at 1 and 3. So the x-intercept occurs when, sorry, let me pause. It's discontinuous at 3 and at 1, okay? Our denominator cannot equal 3 or 1. So now let's figure out what our y-intercepts are. So for a y-intercept, your x value is 0. So we're gonna plug in a 0 for our x value. So here there's a 0, 0, and 0. Okay, so 0 plus 3 is 3. And then 0 minus 3 is negative 3. 0 minus 1 is negative 1. Negative 3 times negative 1 is 3. 3 divided by 3 is 1. If you go back to the original, I think it's kind of easier to look at your y-intercepts this way. If you have a 0 here, that cancels. 0 here, that cancels. 0 here, that cancels. So we just have 3 over 3, which is equal to our 1. Okay, so it's discontinuous at x equals 3 and at x equals 1. And then if we were wanting to graph this, we know that our y-intercept would be at 0, 1. 0, 1. Okay, and so I went ahead and did pull up this graph. And so it looks like this. So here's 0, 1. Okay, these are vertical asymptotes, not holes, and we'll talk about the difference in the next slide. But our vertical asymptote would be at 1. Okay, if you notice here, your graph goes up and it gets super close there. Then down here, it's a parabola that gets super in there. And then also at 3 is another vertical asymptote. Okay, so this is what the graph of what we just found looked like. So we found our y-intercept. Okay, and then it's discontinuous at these two, at x equals 1 and at x equals 3. So let's talk about another one. Let's find the discontinuous here. Okay, so first thing that we need to do is we need to factor the top and the bottom. So here we have our trinomial at the top. So let's factor this. So x squared minus 3x minus 4. So negative 4 goes at the top, negative 3 goes at the bottom. The only numbers that multiply to get 4 would be 4 and 1 that add to get negative 3. And so that's a negative 4. So we have y equals, at the top we have x to the minus 4 and the x plus 1. At the bottom we still have our x minus 4. So now we look at our top and our bottom. If you look, we have an x minus 4 at the top and an x minus 4 at the bottom. So those technically can cancel. Okay, they don't really cancel, they don't go away, but whenever we're looking for our vertical asymptotes, they do. So we still cannot have the bottom equal to 0. So x minus 4 equals 0 would be 4, right? So we have at 4, if you look at our graph, it's a hole at 4. Okay, so our x cannot equal 4 because there will be a hole there. Okay, so if you look at the previous one, we had this one, we had let me clear this. If we look at this one, we had a vertical asymptote at 3 and at 1. Okay, and neither at the top or bottom we could cancel out any factors. Here, we were able to cancel out factors, so we just had a hole. And that is the difference between if there's a vertical asymptote or if there's a hole, it's if you can cancel out any factors. So now let's look here, talking about finding vertical asymptotes. And so we'll kind of look at ones that cancel and that don't, and we'll talk about holes and vertical asymptotes. So again, we do the same thing whenever we're finding vertical asymptotes as we do with holes. We do the same thing. We factor out the top or bottom. In this case, all 3 of these are factored for us. And then we see if we can cancel anything. If we can cancel, it's just a hole. And then if they don't cancel, they're asymptotes. So what are the vertical asymptotes of the graph here? So we have x plus 1 divided by x minus 2 and x minus 3. So, and this says it right here, but we have x minus 2 and x minus 3. We cannot have x cannot equal 2 and then x cannot equal 3. Okay? So, if we look, we cannot cancel x plus 1, x minus 2, x minus 3. None of those are alike. We can't cancel anything. So that means that these are your vertical asymptotes. Okay, so they're vertical asymptotes at x equals 2 and at x equals 3. So they're going to be straight up and down, invisible lines. Our graph will never cross there. Okay, so here we have x minus 2 over x minus 1 and x plus 3. So look to see if we can cancel out anything. We cannot. X minus 2, x minus 1, x plus 3. None of those are the same. So we just set these equal to 0. So they are vertical asymptotes, and I do VA, vertical asymptotes, and then we'll have horizontal asymptotes. But VA, our vertical asymptotes would be at x equals 1, and at x equals, its opposite, negative 3. For both of those, negative 1 is a 1, positive 3 is a negative 3. Okay? B, so we have an x minus 2 over an x minus 2 and x plus 3. So if you see here, we both have an x plus 2. Those kind of cancel, okay? So what this means is our vertical asymptote, it would be what doesn't cancel. So this x plus 3, so that would be an x equals negative 3. We have a vertical asymptote there, and then we have a whole at what cancels, the x minus 2, so at x equals positive 2 is your whole, okay? So if they cancel like this, you have a whole where they cancel, and the other one's a vertical asymptote. If nothing cancels, then they're just asymptotes, okay? So now let's talk about horizontal asymptotes. Oh, I don't know why this isn't working. There we go. Okay. Horizontal asymptotes are straight left and right, so this will be your y equals because it goes through your y-axis. So what we do here is we compare the degree, so your highest exponent, you compare your degree to the top over the bottom, okay? So the numerator top m over the numerator bottom n. Okay, so the degree of the top over the degree of the bottom. And then if your numerator degree is higher than if your denominator degree is higher than your numerator, then your horizontal asymptote is y equals 0. If your numerator is bigger than your denominator, then there's no asymptote. And then if m equals n, so if these are the same degree, then you look at their coefficients out front, and that would be a over b. That would be your horizontal asymptote. Okay, so let's look at some examples. So we have y equals 2x over x minus 3. So first we need to look at their degrees. Okay, so that's your exponents. The exponents here is 1, exponent here is 1, and that's our highest. So 1 over 1, m over n. M is equal to n. These are the same degrees. So if they're the same degrees, we look at the numbers out front. So here we have a 2 and we have a 1. So y equals 2 over 1, or y just equals 2. So at y equals 2, there will be a vertical asymptote. Okay. So now let's look at some more examples. So we have y equals x minus 2 over x minus 2, x squared minus 2x minus 3, sorry. So horizontal asymptotes. Luckily with these, we don't have to factor. Okay, vertical asymptotes, you do have to factor because we have to worry about the bottom. Okay, here we're fine. We just have to look at the degrees. So with our horizontal asymptote, we look at the degrees. So our highest degree here is 1, highest degree here is 2. So, and again, this is m over n. So here, our n is bigger than our m. So n would be bigger than our m here. The bottom is bigger than the top. So that means your horizontal asymptote would be y equals 0. Okay. Here at C, we have y equals x squared over 2x minus 5. Again, we just look at the degrees. So here we have x squared, so 2 over 1, 2 over 1. So m is bigger than n. Okay, 2 over 1, the 2 is bigger than the 1. M is bigger than n, so that would be this one. So that means there's no asymptotes. Okay, so top bigger than the bottom, no asymptotes. Bottom bigger than the top, your asymptote is at y equals 0. And then here at this one, if we have negative 2x plus 6 and then the x minus 5, now we look at the degrees here. This is a 1 over 1. If you notice, they're both just x's. So those kind of cancel out. That's how I think about it. They cancel out and you just look at your front. So y equals negative 2 over 1, or just y equals negative 2. So your asymptote would be at negative 2. Okay? So that is that. So now let's talk about, lastly, what a graph, how we could figure out to actually graph this. So first step, what you need to do is, what is the graph of the rational function? X squared plus x minus 12 divided by x squared minus 4. Okay, first thing that we always need to do is factor. Factor the top, factor the bottom. Okay, so x squared plus x minus 12. So two numbers that multiply to get negative 12, but add to get the 1. Okay, so I'm thinking of 4 and 3. Okay, so negative 12 and then 1, so it'll be 4 and 3, they're 1 apart. We need a positive 1, so this has to be a positive 4. Okay, so our top would be x plus 4 and x minus 3. Okay, now we do the bottom, and we have x squared minus 4. Okay, so this is the difference of two squares. So this would be x plus 2 and x minus 2. Okay, so, and I'm just going to kind of show like, so y equals, nothing can cancel out. So we have no holes. These are going to be asymptotes. Okay, so let's find our asymptotes. First, let's find our horizontal left and right. With horizontal, you look at your degrees. So back to the originals where I'm going to look. So if you have x squared over x squared, those are the same degrees. So we look at the numbers out front. So 1 over 1. So our horizontal asymptote will be at y equals 1. So I'm going to kind of come down here and make my graph. Horizontal asymptote left and right will be at y equals 1. So at 1, we'll be through there. Okay, now let's talk about our vertical asymptotes. We've already factored x plus 4, x minus 3, x plus 2, x minus 2. So our vertical asymptotes, we have to look at our bottom. We know we're not having holes because nothing can cancel, so these are both vertical asymptotes. So here would be a negative 2, here would be a positive 2. So at negative 2 and at positive 2, okay, so we have 1, 2, 3, 4, 5, 6 parts where our graph can be. So now let's look at finding intercepts, and then we also need to plug in points to figure out more, which that step isn't on here, but we'll talk about that. So when the numerator equals 0, so y equals 0, so when your numerator equals 0, to find your x-intercepts where it crosses your x-axis, so this would be, opposite of that, so this would be x equals negative 4, and this would be x equals positive 3. So whenever it crosses your x-axis would be at negative 4 and positive 3. So 1, 2, 3. Sorry. 1, 2, 3, 4 would be that coordinate point. So this graph is going to be down here, right here, sorry. Then here we have our 3, 1, 2, 3 would be right there. So this graph would be right in there. Okay, now let's talk about our y-intercept, where our graph crosses our y-axis. Okay, so this would be, and I'm going to look back at our original equation where we plug, so for zeros, our x's, that would be your y-intercept. So when your x value is 0, whatever your y value is would be your y-intercept. So if we plug in 0 here, 0 here, 0 here, well those cancel, so we just have negative 12 over negative 4. Well, that simplifies to be a positive 3. So that coordinate point would be 0, 3. So we have 1, 2, 3, so it would be up here. So we know our graph will be over in here, and then here, or sorry, it needs to be there, and in here. Okay, and we can plug in more points. I did that. If our scientific calculator, I plugged in, like if we had an x value of negative 3, our y value would be negative 6 over 5. Okay, negative 1 would be 4, and then 4 would be 2/3. So -4 would be, or -3 was -6, so about right there, which is what we have. 4 would be the 2/3, which is what we have. And then the -1 was 4, 1, 2, 3, 4, which is about what we have, okay? Whenever you're done, you can always use Desmos to check it. And so if we look at our graphing calculator here, that's what we have. We have our vertical asymptote at -1, or -2, sorry, because these are up by 2's. Then we have our y-intercept here. Okay, we had our horizontal asymptote at 1. And so that's what our graph looks like. And so you can be able to, just by finding your asymptotes on MathXL, you should be able to find what your graph looks like and match it there. But I kind of wanted to go into detail about exactly what to do to find that exact graph, okay? So that is it for 8.3. There are 8 total questions. So you guys got it. Find your vertical asymptotes, horizontal asymptotes, your holes, and you're good, okay? And also, go Pokes, forever and always, loyal and true. Go Pokes.